Hello, kings and queens. Welcome back to our second video of the week. Today we're going to be talking about how to solve two-step equations, but this time we're going to be looking at rational numbers. So per usual, we're going to go ahead and start by saying our class affirmation. Today, I will do my best to be my best. What I do today will make a difference in my life. My choices will affect me and those around me. I will listen, I will be honest, I will respect the rights of others. I will learn something today, because today matters and my future is built on one now at a time. So let's go ahead and jump into it. So I have gone ahead and given us two examples of what a two-step equation with the rational numbers would look like. We have this equation here and this equation here. Notice that the equations, the way they're set up is the same as what we talked about earlier this week. Now we are just seeing fractions and decimals instead of integers. So just a real quick refresher, we had three main components to these two-step equations. We had variables, coefficients, and constants. A reminder, a variable is a quantity represented by a letter. So in this case, a variable would be what? C. And in this equation, the variable would be x, the quantity being represented by a letter. Coefficients are the number being multiplied by the variable. So over here, we said the variable was c. The number being multiplied by c is -5. So that's my coefficient. And likewise over here, 1/2 would be my coefficient because that's being multiplied by x. And lastly, we have constants. Constants are fixed terms or numbers without any variables. So the constants over here would be -16.2 or the -16.2 and the 3.8, just the numbers by themselves. Likewise, over here, we'd have the 8 and the 12. Another quick refresher, we're going to follow the same exact type of setup that we did earlier this week, that we went over earlier this week on how to solve these types of equations. So first and foremost, you're going to find the value for the variable that makes the equation true. In other words, what can I plug in for c that will make this side of the equation equal to this side of the equation? Or what can I plug in for x over here that would make this equal to 12? So they both be 12 on both sides. Middle step, step number 2. This kind of actually explains the process. So we're going to want to remove the constant by using either addition or subtraction. In this case, we want to get rid of the 16.2 by adding it onto both sides, since addition is the inverse operation of -16.2. Then, once you have your constant moved over, you're going to remove the coefficient that's attached to the variable by using either multiplication or division, just depending on what the inverse operation is. So if I had 5 times c equals something, I could get rid of the -5 by using division, since that's the inverse operation. Okay, we're not really going to get into the numbers yet. I just want us to kind of think about the process. So remove the constants using addition or subtraction, and remove the coefficients using multiplication or division. Okay. Please keep in mind you want to keep the equation balanced. Whatever you do on one side has to be done to the other as well. You got to keep it even. So now we're actually going to jump into seeing some problems with actual numbers. I also want to give you guys a heads up. A lot of what we're going to be reviewing during this lesson won't just be the mechanics of solving two-step equations. We're also going to be having like real quick refreshers and reviews on how to multiply, divide, fractions, decimals, all that kind of stuff, because it comes up now that we're dealing with rational numbers. So let's get into it. Over here, I have this following two-step equation. 1/2 x minus 8 equals 12. So I have variable, coefficient, and constants. First step, was to remove the constants by using addition or subtraction, right? So in this case, if I had -8, what would be the inverse operation? Adding 8. So I'm going to go ahead and add 8 onto this side. If I add 8, excuse me, onto this side, I have to do it on this side as well. So I'm going to go ahead and show that out. This ends up canceling out, -8, +8. This zeroes out. And I end up getting this, 1/2 x equals 12 plus 8 would be 20. Okay. Now, I have the constants gotten out. I have the constant removed, which is awesome. I just have one thing left to do now. I'm going to get rid of the coefficient by using either multiplication or division. So in this case, I would be using division because that's the inverse operation of multiplying, right? So divide by 1/2 and divide by 1/2, right? This 1/2 would get canceled out. So I'd just be left with x equals whatever 20 divided by 1/2 is. I don't know that yet, but I'm going to show you guys what I would do to come up with that solution. There are a ton of different ways to do it. So I do want to encourage you to go and use the approach that you're most comfortable with. If you can figure out what the solution to 20 divided by 1/2 is some other way than what I'm about to show, more than welcome to use it. I'm just showing you what I would use. So I'm going to rewrite 20 divided by 1/2 is 20 over 1. Instead of dividing by 1/2, I'm just going to multiply by the opposite. So multiplied by 2 over 1. Remember, you can just multiply by the reciprocal instead. If I cross multiply, that gives me 40 over 1, which is the same as 40. So my solution would be x equals 40, right? Again, I really do want to stress that all of us, I'm sure that you guys, a ton of different people in the class might have different ways of solving 20 divided by 1/2. Please use the method that you're comfortable with. I usually lean on this method just because it makes most sense in my head. So now we have another problem over here. I'm going to ask you guys press pause on the video and try to work through this problem set on the right-hand side. As soon as you are done, you can press resume play where you can verify your work by seeing if you had the same solution that I had. So for those of us who are back with me, let's go ahead and jump into it. We have 3 plus 3/4 x equals 24. First step is going to be to remove the constants by using addition or subtraction. In this case, I'm going to use subtraction. So I take away 3 from both sides. This cancels out, so I'm just left with 3/4 x equals 21, right? Now, the next step to just have it be x equals something will be to get rid of the coefficient by using either multiplication or division. Since 3/4 is being multiplied by x, the inverse operation would be division. So I'm going to divide both sides by 3/4, right? This cancels out, so I just have x equals whatever 21 divided by 3/4 is. I'm going to go ahead and use the same multiplying by the reciprocal method that I used before to figure out what that is. So I would just go ahead, but again, if you have a different method, it's all you. But what I do is 21 over 1 multiplied by the reciprocal, or the opposite, which would just be 4 over 3. Now, this is another really quick refresher on multiplying fractions. Um, there's a number that can go into, I can multiply this across and that would be fine. I would get an answer. That I have to simplify further. But what I'm going to do is just simplify it now. I know there's a number that goes into 3 and 21, and that number is 3. So I'm going to divide the 3 and the 21 by 3. So if I do 3 times 3, that would get changed to 1. And if I had 21 by 3, that would get changed to being 7. Right? Again, if you didn't want to do that now, that's more than fine. You would just have to simplify your fraction later on. So I'm just getting it out the way now. So now I can go ahead and cross multiply. 7 times 4 is 28. And 1 times 1 is 1. 28 over 1 is the same as 28. So my solution would be x equals 28. And that's that. Okay, so we're going to go ahead and do another example, just to make sure we're all on the same page, that's set up pretty similarly. So just like we did before, I'm going to go ahead and walk us through the left-hand side, and the right-hand side is going to be for practice. So the equation I have is r divided by -4 minus 2.5 equals -2. Variable, constant, or I'm sorry, coefficient, whatever is attached to the variable, and constants. First step is to get rid of my constants by using addition and subtraction. In this case, I want to use the inverse operation. So I would add 2.5 onto both sides. Okay. Perfect. So this would get canceled out, and I'd just be left with r divided by, or over, -4 equals -2 plus 2.5 gives me 0.5, or just 0.5. You might have to tap into some prior skills on using number lines here, or if you just kind of knew that in your head, that's fine. But remember, now that we have negatives being thrown into the mix and decimals and fractions, we just got to be mindful of what our signs are, okay? So -2 plus 2.5 is 0.5. So now I have a variable, a coefficient, something attached to the variable, and a constant. In order to get rid of the coefficient, I'm going to use the inverse operation. So in this case, this one's the first one's a little bit different. Instead of these being multiplied, they're being divided by each other. They're being divided. So the inverse operation would be multiplication. So I'm going to multiply both sides by -4, right? Multiplied by -4. If I have a divided by -4 and a multiplied by -4, those cancel out. So on this side, I'm just left with r equals, and then over here, I have 0.5 times -4. I'm going to go use this workspace to solve that because I don't know that off the top of my head. If you do feel comfortable with that math in your head, that's all you, but I'm just going to work it out. So I'm going to go ahead and use long multiplication here. Oops. Here we go. 0, so I'm going to write out the decimal, 0.5 times -4. I'm just going to leave the negative over here because I'll add it at the end. So first things first, when I'm multiplying, 5 times 4 would be 20. So I'm going to put the 0 here and carry the 2. 4 times 0 is 0. But if I add 2 from what was left over from before, I'd have 2. Then, since I had one decimal, or one decimal place, I'm going to put that there, and a positive times a negative is a negative. So my solution here would be r equals negative 2.0, or if you just like to write it as negative 2, that's more than fine as well. They're the same thing. All right, so again, a little bit of a review with multiplying and having positives and negatives. That shouldn't take away from the same process that we followed with solving these equations, okay, guys? So don't get too tripped up about seeing decimals and fractions. The process is the exact same, all right? So again, go ahead and press pause on the video and try to work through this problem over here. As soon as you get done, you can press resume play where you'll be able to follow along with my work. Okay. So an identical type of equation, we have constants, coefficients, and variables. First step, like we've been doing, is to move the constants by using addition or subtraction. In this case, what would we do? Move this 6 over. And what would I do to move it? That's right, add a 6 on both sides. This cancels out, so I'm just left with 2/5 c equals 30. Now I have a coefficient and a variable. To get rid of the coefficient, I would use either multiplication or division. In this case, I would divide, since these are being multiplied by each other, both sides by 2/5. This would cancel out, and I'd just be left with c equals whatever the answer to 30 divided by 2/5 is. Again, I don't know that in my head, so I'm going to use this blank space over here. I'm going to use the same method that I used before. Feel free to use a different method if you thought it was easier, but I'm going to go ahead and write out 30 over 1. Instead of dividing, I'm just going to multiply by the reciprocal. So multiplied by the opposite, so 5 over 2. And now I'm set up. Again, if you wanted to multiply 30 times 5 and then divide it by 2, you could. I'm going to simplify beforehand. So there is a number that can go into 2 and 30, and that is 2. So 2 divided by 2 would give me 1, and 30 divided by 2 would give me 15. So now I can cross multiply. 15 times 5 is 75. And 1 times 1 is just 1. So 75 over 1 can be rewritten as 75. Therefore, my solution to C over here would be C equals 75.